Today, I'm going to talk about a project that we completed here in Maryland last summer called Glenmont Forest Green Streets Retrofit. And the project entailed doing a water quality retrofit in a 1940s, 1950s neighborhood in Wheaton, Maryland called Glenmont Forest, which is just outside the Beltway in the suburbs of Washington, D.C. This project differs a little bit from some of the others we're hearing about today in that the entirety of the project was installing stormwater management quality facilities in this older neighborhood. So very interesting from that standpoint. The goals of the project were to pick up as much drainage area from the roads as possible and treat the first inch of runoff, which is considered water quality control by the state of Maryland and the MDE. The second goal of the project was to help restore a stream restoration project that was done in 2005 by the county in the lower watershed in which this neighborhood is located. So they're investing in the success of that project long-term as well. So as you can imagine, doing a retrofit project in an older neighborhood that, as we'll see in a bit here, is as dense and crowded as any you'll find, is the fact that everything is existing. Not only the above, at-grade, and below-grade utilities, but the residents live there. There's street parking, there's school buses, all of the things that a bustling neighborhood sees has to exist and coexist with the construction of the facility. So that made the entire project very, very challenging. Now, the design team that was led by RK&K out of Baltimore had to find out where these facilities could be located and locate existing utilities. This graphic was put out by the agency in charge of the project, Montgomery County DEP. And what it shows is basically there were three different types of stormwater facilities that were installed throughout the project. Two of them are very similar: bioretention, rain garden, and green streets, indicated by number 1 and number 3 on the graphic here. And the second is where Contech's involvement was centered, was item number 2, tree boxes, which a product name we call is Filterra. So all of these facilities were used across the site to provide water quality control, along with measures to increase public outreach and community involvement in maintenance and upkeep of these facilities for the long term. So for those of you not familiar with Filterra, the graphic here shows essentially what it is and how it works. So it's a high-flow bioretention technology that is designed to intercept the first flush of stormwater runoff, in this arrangement directly from the paved surface, a parking lot or a road, pass that water very rapidly through the filter media inside the structure, and then drain it away rapidly to a downstream storm drain connection. Higher flows during large storms will simply continue down the curb and gutter and enter a inlet or catch basin or curb cut. And in this case, the high flow bypass shown on the right side of the graphic are all the existing inlets that were already there providing drainage for the site. So a few examples from site plan snippets and the challenges that were found in all 20 locations for the Filterra facilities and the remaining facilities as well throughout the site. So of course, being installed in those narrow locations, as I described earlier, they had to do many things at each location. This particular example on Ivanhoe Street, they had to fit the system inside between the curb and the sidewalk. They had to avoid a driveway. And of course, they had to avoid the underground utilities, in this case, a water line existing and a gas line existing, by the pipe that allows the water to drain out of the Filterra and reconnect to the downstream storm drain. So all of these things came to play at every location. What the design team had to do was make sure that the system fit, that it was sized properly for the drainage area, and that during construction that these obstructions could be avoided. Now, normally with a box like this, which weighs about 15,000 pounds, they would simply pick it up from the top with a crane, with a steel cable on a spool, and swing it into position, lower it, and release the cables, and you'd be off and running. But in this case, because of the overhead utilities, they couldn't do that. So the contractor determined a way to use a very unusual piece of equipment for these facilities, a high-capacity forklift. So they had to lift it with the forklift from the bottom instead of pulling it from the top, move it into position away from where the delivery vehicle could pull up, again because of the narrow streets, move it over to the excavation where the facility is going to be installed, and then pick it up from the top at that point using the forklift and set it in place. So once they put the top on of that box, That was it. They were done. You'll notice that after the top's put on, they cover up the tree grate with plywood to protect it. And then they remove a strip of asphalt in front of the unit and then pour the warped gutter pan. Because remember, what they're doing is providing a low point to allow that first inch of water to be intercepted and then higher flows to simply be bypassed into the existing inlet. So hydraulically, it's exactly the same as it was before they built it. And then how it's going. So this is another Google Maps Street View project that happened to be taken, luckily, after construction. And you can see the unit on the right-hand side with the trees in place and the replaced strip of asphalt and warped curb and gutter pan. So the graphic that I just showed you earlier about how Filterra works is illustrated again here with a different unit on the project. You'll notice flow approaching from the right enters the unit through the warped gutter pan, which was poured after the box was set, and bypass goes past the grade break at the junction of the new gutter and the old gutter and bypasses into the existing inlet. Couldn't be simpler hydraulically and couldn't be simpler to install for the contractor once they figured out the equipment issues. So why did they use Filterra on this one? I'll let you read through the bullet points, but the highlights I think are the first check mark, the drainage area to filter bed area ratio of 220 to 1 really made the best use of available space in terms of the credit they were picking up for drainage area that was going to be treated, given the constraints that we saw earlier. The maintenance, so the third check from the bottom, the maintenance of the Filterra, not only is it very simple, just replace the mulch and take care of the tree, but it's actually the same maintenance for the other two types of facilities. So it'll make the community involvement in the project and the pride that they have in a new amenity very, very simple because it's all the same, no matter whether it's the Filterras or the bioretention roof bioretention pond areas or Green Street bioretention areas. And of course, Contech prides itself on the service that we provide to our engineering clients, everything from going out to the site to look at individual locations, to assess them, to providing deliverables such as drawings, cost estimates, and hydraulic calculations. So I hope everyone found this project interesting.